In lesson 2.1, we are going to be looking at measuring, and specifically how accurate we can measure, and then how precise can we say our measurement is. So we're going to look at the accuracy of the device, the precision of the device, and therefore how accurate we can measure. So even when you look at this thermometer pictured on here, when you ask what's the temperature outside, how accurate can you really say it, or when you have a watch, or when you're using a ruler? So to illustrate this, let's just take a look at this situation here. We have a line, which is right here, and the question that I would ask you was, well, how long is that line according to the ruler that we have there? And I'm looking at it, and I can see it ends kind of, looks like 9.5678, just past 9.8. So I'm going to say that's 9.8 centimeters. But then how do we account for this uncertainty of, well, how accurate really is that 9.8 centimeters when we give that information to somebody else? So what we're going to be doing when we list our measurements is, when we want to talk about the uncertainty, is we are always going to cut the uncertainty in half. So in this case, we can measure to the nearest millimeter. So when we talk about a millimeter, 1 millimeter is 0.1 centimeters. And if we cut that in half, divide that by 2, that's 0.05 centimeters. So we can say that this is accurate, this 9.8 centimeters is accurate, but we say, well, plus or minus, give or take, 0.05 centimeters. We always take the most we can accurate and then cut it in half, and that is called your measurement uncertainty. And that allows us to be accurate in the reflection of our measurement. So let's take a look at some situations here. The first one, a baker sets an oven timer that displays 1-minute intervals at increments, 1-minute increments to 45 minutes. So if you look back at what we had on the previous page, we say the measured value. The measured value is 45 minutes, is what the oven timer is set to, plus or minus the uncertainty, which is always half the value. So if it's 1 minute, we take half a minute, that's 30 seconds, we say plus or minus 30 seconds. That's how he would list the precision and the uncertainty. So the first part is your precision, the 45 minutes. The second part is your uncertainty. Let's take a look at this one. A jeweler weighs 1.243 grams of gold. What's the measurement? Oh, 1.243 grams. Now the uncertainty isn't directly listed as it was on the oven timer, so what we then do is we look at the last digit and we say, well, what place value is that? Tens, hundreds, thousandths. So if I'm talking about this value, it's say, well, the nearest thousandth would be that. Oh, wait, we're supposed to cut that in half. So half of that would be 0, another 0 and 5. And that would still be also in grams. So you take the last digit of the accuracy, or of the measurement. Now this last one is interesting. 1,200 meters. Okay, 1,200 meters. That's easy, that's my measurement. But the plus or minus part becomes interesting, because how do we know how accurate they measured? Was it to the nearest 100? Because if it was to the nearest 100, then half 100 is 50. But what if they measured to the nearest tenth? We don't really know for sure. Well, if it was to the nearest tenth, then half of 10 would be 5. Well, what if it was to the nearest 1? It would be 1,200 meters plus or minus 0.5 meters. And clearly the bottom one is the most precise, and the top one is the least, or give or take 50 meters. That's a lot of distance. So often when the measurement's made, they sometimes will mark the digit to where they measure to with a line. So if they put a line over the 0 there, that means they measured to the nearest tenth, and you would have to then consider that when you write down your measurement. Let's take a look at this situation. There's a piece of molding, which is, if you look at the diagram or the picture on the bottom right here, molding can be crown molding or just regular molding. It's just put up to kind of cover seams when you are finishing a room. And you can see the rulers here, the tape measures, have different accuracies. So which one is more precise? Which one has more precision? And you can see the ones with more markings allow you to be more precise. And when you're measuring, you want to consider your job and what you're trying to do and how accurate do you need to be. And generally speaking, with wood, you have to be less accurate measuring than you would with metal, which has to fit perfectly often. And so if we're looking at this situation here, a lot of the questions will ask you, what do you think makes the most sense here? And I definitely would not use tape measure number 1 because that doesn't even allow me to get to the nearest half an inch because there's no half-inch markings, whereas in tape measure 2, yes, it marks half inches, or maybe centimeters, sorry, not inches. And then the third one is the most precise, and I would use the third one because I would like to be as precise as possible to make it fit the best. And if you were building a fence now, I don't really care about anything but the nearest centimeters. When you are talking about the top of a fence post, whether it's off a centimeter or not, no one's going to really notice as long as they're straight and in line, and that you would use a level to determine that. So let's take a look at some calculations now. A kitchen cabinet installer is laying out a kitchen design. She plans to install the fridge. She measures the fridge to be around 71 centimeters plus or minus 0.5, and the other one's 76. And she calculates their combined width. So when we look at these, how could we talk about them put together? And if I think of 71 plus or minus 0.5, if I go down 0.5, that's 70.5 centimeters to 71.5 centimeters. And we talk about the stove, 76 take away 0.5 is 75.5. To plus 0.5 would be 76.5. So when you talk about the range of the totals, you'd have to add that together. So 140, 145, 146 centimeters to 147, 148. And you see, if you think of the middle number there, you add them together, that's 147 centimeters plus or minus a centimeter. And you'll notice that this value corresponds to this, and this value corresponds to those added together. Okay, I don't want to stretch this out too far. We can do more examples together. There are some definitions for you to look at, and there's also a hint on one of the problems. There's a build your skills assignment, which you need to get done, and once you're done that, make sure you get your check done. Don't forget you also need to get a math on the job done, and also don't forget to look at kind of the history of math at the end of each section as well and do one of those. So that's it for first part of chapter 2, and we'll be on to the next part soon enough. See you later.